Hello, my name is Tanayo.
Hello, my name is Idril Bongaling and we are going to present our P3 of ITC.
So I'm gonna be doing the first part of our project, which is kinda the same as the P1 that we did, but the main difference here is that here we have the axis and also we have our calc button in order to perform our operations. So here is our selector. So whenever we have 0, 0, that means that we have an AND. If we have 0, 1, that means that we have an OR. If we have 1, 0, that means that we have a NOT in the ACE input. And if we have 1, 1, that means that we have an XOR. So for the first case, let's do for the B inputs 1, 1, 0, 0. 1, 1, 0, 0, yeah. And for the A inputs, let's do 1, 0, 1, 0. So if we press calc, this should show us a 1. This is showing a 1 because the AND operation is being done bit by bit. So it's comparing each bit by bit, and the combination of all the bits is going to be the number that is showing here. So for the OR, here, let's do our OR. If we have the same numbers, if we have 1, 1, 0, 0 in the B's input and 1, 0, 1, 0, and if we press calc, this should show us a 7, and it's the same logic because it's doing the or bit by bit, and then the combination it shows here. So now let's do our NOT A first. We have here our NOT A 1, 0, and for this one, let's say that here we are here we are doing our NOT A. So for our NOT A, if we have 0, 0, 0, here this should show us a -1 because the first bit of our input is representing the sign. So we know that if we have a 1 in the first bit, that means that it's going to be negative. So here our -1 from the 0, 0, 0, if we negate everything in C2, that means that we have a -1. So for our XOR, let's use the same numbers as for the previous operations. 1, 1, 0, 0 in the B's, and 1, 0, and 1, 0, 1, 0. So if we press this, we should expect a 6, and it's exactly what we got.
Okay, now I'm going to present to you the arithmetic mode, but things we have to take into consideration first is that we have our calc that updates the value, and we have our cell 2, the bit that determines if we are switching to arithmetic mode. And we have to keep holding this because it's a push button. For every time that I hold this, it's gonna be 1, which means it is selecting the arithmetic mode. And if I release it like this, it's gonna be in the logic mode, the ALU. So in our case, if I press this, we are automatically in the arithmetic mode, and this is the first case of the arithmetic mode will be an addition. So from here, let's perform an addition. We have our A inputs. Let's do 3 plus 2, and we press calc alongside holding the cell 2. It should give us a 5 because we are adding. Let's do another one. Let's say that we are doing, let's update the calc first. We are saying that we are doing a 1 plus 1. Let's hold this, we are getting a 2. Okay, fantastic. In the case that we want a case that we have an overflow in addition, we're going to have a 7 plus a 1. That will give us overflow because we cannot represent this number. We cannot represent 8. So we are getting an overflow. Wait, did you end it? Now let's do a subtraction. For the subtraction, it's just gonna be that we know that I told you before, you before that we have cell 2 here, and for every time we hold this, we are in the arithmetic mode, and we set this as 1 to indicate that we are in subtraction mode. So let's do a test case. Let's do 5 minus 3 expected a 2. And if we do, oh sorry, let's update that first. And if we do 2 and a 5, we are expected a -2. Okay, fantastic. And let's update this, and let's do a case where we want an overflow from subtraction. Okay, in the case that we want an overflow for subtraction, let's do a case where we have 7, and let's make b as all the bits. We see we cannot have that because we cannot represent this number. We have our overflow, and we can do another case. Update the result, do another subtraction, and let's say that we have 8 plus 1. Sorry, 8, and let's do this one a 1. We can't represent this because in our range of values, this value is not representable. So